In the two-card slab, we're going to describe the motion of two cars as their constant speed or an acceleration. We can set up a motion detector to graph the motion of the large Jeep. Here is that graph. This distance versus time graph, every time you go over half a second, you go up the same amount. It's going equal distances in equal amounts of time. This line is a slanted line going up to the right. Connecting 2 points and drawing a line between them, we can see that. To find the slope of the line, we need 2 points, 0.25, 0.29, and 3.0, 1.42. To find the slope of the line, we need to use the slope formula. y2 minus y1 divided by x2 minus x1. We start by subtracting the y's. The y's are right here. 1.42 minus 0.29. We divide that by the x's, which are right here. 3.0 minus 0.25. The slope of a distance versus time graph is speed. This time, the motion detector was set to graph velocity versus time. Let's analyze this line. We pick 2 points. A line between them shows it's more of a flat horizontal line. The first point is 0.25, 0.45. The second point is 3.0, 0.44. To find the slope of the line, we need to subtract the y's. 0.44 minus 0.45 divided by the x's. 3.0 minus 0.25. Be sure to round to the closest tenth. The slope of a velocity versus time graph shows the acceleration. Now we can use the motion detector to graph the small Jeep. This graph shows us that every half second, the car was covering more and more distance. This line is definitely not a straight line. By putting straight lines near it, we can see that it's sloping away. It's a curve going up to the right. Here's the motion detector graphing for the small Jeep a velocity versus time graph. To analyze this graph, we put 2 points. A line between them shows it's slanting up to the right, with the first point, 0.25, 0.10, and the second point, 3.0, 1.1. To find the slope of the line, all we have to do is subtract the y's, subtract the x's, and divide. Be sure to round number to a tenth. The slope of a velocity versus time graph shows the acceleration.